Hi everyone, welcome to today's guest speaker session. So today we have Sadegh Jafari. He's a PhD researcher in linguistics at Ghent University, affiliated with the LT3 research group. His research focuses on empathetic multimodal conversational agents with particular interest in how language models can understand, generate, and align emotional signals across text, speech, and visual modalities. So, yeah, thank you for accepting our invitation, Sadek. So, yeah, I'll leave it to you.
Mhm. Uh, s- Suppose that we have a AI as a teacher and a student who wants to learn English as a second language, and the student tried to make a sentence with apple, and he said, "I am an apple," but the normal robot respond, "Wrong, try again." So the student may feel frustrated in this situation. But suppose that we have a empathetic and multimodal AI agents. As a teacher, now the AI agent can see that the t-shirt of the student is green and the apple also is green. So it responds, haha, you do look like a green apple in green, but I think you meant I like green apples. So in this situation, maybe the student is more encouraged to keeping learning the second language or English language. So why empathy is important? First, because it builds confidence and motivation. And also in language learning process, empathetic correction keeps the students more encouraged in their learning process. So maybe someone says that, so let's train an empathetic model, but wait. Before thinking about training new empathetic model, it's better to think about the definition of empathy and the standard way for evaluating it. So in human-centered AI, for having empathetic model, the stepping stone is having more emotional system. So if we want to make it, we first need to make emotional system. And also empathy itself has two different parts, one cognitive and one affective. Cognitive means it's about understanding, it's about understanding the content of the conversation between user and the agent. And affective is about more emotional responses. So for robots, we mostly have cognitive empathy because affective empathy is just for humans. And also, for example, for cognitive empathy, if we have person A and he or she says that my grandmother just died and we were really close. And if our agent respond that I'm sorry, I know you are sad and that what are going through is hard, it means it tried just to understand the situation to show that the robot is actually understands the situation. So, but with the same example, if the robot actually respond, I'm sorry to hear about your grandmother. I know you miss her. I'm here for you. So it's a bit weird, I think, if the robot responds something like this, because I'm here for you is for just humans. So affective empathy is almost impossible in AI agents. We have different type of definition for cognitive and affective empathy, different categories, as you can see here. And in our timeline, in our project, we have this schema. We have two different parts. We have emotion and empathy, and each one has three different steps: definition, evaluation, and model training. For emotion definition, we had 26 different categories. After clustering, we finally have 7 different emotion labels like disappointment, contentment, disgust, and so on. And this is one of the example in our data set. The dataset is unique that was built in Flanders AR project, in our project. This is a multimodal dataset with different emotion labels in different modalities like text, audio, and video. And also silence video, 4 different emotion values. For evaluation, for each modality, we did different type of evaluation, human evaluation and automatic evaluation for different generative models. As you can see here, for text modality, we have 5 different LLMs or generative models. We also have human evaluation, and we have 15 different automatic evaluation metrics. For audio, also, we have 10 different audio generative models. We haven't yet have human evaluation, but we are doing this part, and we have 11 different evaluation metrics. And for video, finally, we have 4 different generative models. We have human evaluation and 8 different automatic metrics. And I will discuss about all of these values. And for text modality, we choose GPT 4.1 different type of llamas, Mistral, and GPT 4o mini. And we have 15 different automatic metrics in 4 different family. Some of them use LLM as judge, but some of them are, for example, embedding based and so on. But for human evaluation, we choose, because the unique dataset has almost 1,000 samples, we choose almost 300 samples for human evaluation. For 5 models, it means like 1,300 samples in total. So we have 175 annotators. We use prolific application for annotating these generated samples. And after doing human evaluation, we found out that the best model is GPT 4.1, and the worst one based on human evaluation is GPT 4o mini. So this is the table. As you can see here, we have different values for automatic metrics and also human evaluation. Human evaluation is based on the F1 score that we compare the original, the given, and the target of emotions. We compare them with the annotated emotions, with the final emotions that the user in prolific annotated them. So here in the last row, we have correlation. The correlation is the correlation between these numbers and each of these numbers. So if we have higher correlation, it means that the values in that automatic metric is correlated to human results, and it's more reliable. So here we have 2 really high correlation. One is both are in ERS group as emotion recognition score group, family metrics actually. And for both of them, for one of them is 99%, for another one is almost 95% in correlation. Both use GPT-5 nano, one in 0-shot setting, one in 1-shot setting. But maybe someone may say that if we use LLM as judge, especially the big ones like GPT, they have more correlation, but it's not true, because for this family, for EAS, that means emotion absolute score, the correlation is negative, but using the same LLM as a predictor. So it's really rely on the metric itself and the prompt that it used. And these are about the embedding scores, embedding analysis, and these are different type of actually metrics. But the most important one is ERS that used GPT-5 nano as in one shot or zero shot setting. So the best one is, as I mentioned before, ERS GPT-5 nano in one shot setting with more than 99% correlation. So we can use this model as a evaluation metric instead of human evaluation, because the correlation is almost one, near to one, and we can use it. It's really reliable. And this is one of the samples in our database. This is the original text in unique dataset as a transcript of the videos. And this is the original emotion there. This is the, because for each sample we have 5 annotator in prolific. These are the emotions for that are annotated by them. And neutral text means that for being sure that the model just use their own knowledge for making emotional text, we first neutralize our text in our database by removing some emotional clues, and then ask them to regenerate emotional text from neutralized version. And then we compare this version with original text. After that, we did an interesting follow-up experiment. The question here is, emotion understanding is equal to or is similar to emotion generation score or not. For example, I mean, in most of the papers or researches, if someone wants to measure emotion generation score, they measure some classification scores like emotion recognition score by using some data sets, emotional data sets, and then they say, okay, this one is the best in emotion understanding. So it's we can conclude that this is better in emotion generation. So we defined 4 different metrics here for measuring this idea. Here, original emotion recognition score means that um, testing or validating the original unique dataset, or that we compare original emotion with the predicted one using different LLMs. This is emotion generation score. It means comparing the original, the target emotion with the annotated one using prolific application. This is for understanding also on generated text, that we compare the predictions of LLMs with the labels that are annotated by people in prolific. And finally, this one is emotion consistency score. What does it mean? It means that if we ask an LLM to generate happy sentence, if it then generates something, and we ask it again, what is the emotion here in this sentence? If it says something else, for example, it's neutral, it means it's not consistent. It generates something that we ask it to generate something in happiness, but after doing this, if we ask it what is the emotion here, if it mentions something else, it's not consistent. This is that score. So we are also calculated confusion matrix for different metrics here. And for almost all of them, the problem is most of the errors are related to the confusion between contentment and joy, because the meaning of those emotions are near to each other, and most of the people and models make some mistakes here. To address this problem, we made an we made a cost matrix for this purpose. First, we made a manual cost matrix, but after comparing it with the automatic one, this is the automatic one, we decided to use automatic cost matrix. Cost matrix means, for example, if we ask the model to generate something in disappointment, if it makes something neutral, the cost is 0.3, but if it makes something joy, the cost is near 1. So we have different costs for different values. Using this cost matrix, we uh, calculate again all the values for different matrix, for these 4 different matrix, and we again calculate correlation between these 4 matrix. And we found out that the correlation between EGS as an emotion generation score and the rest are like 70%. So it means um, it's the reliability of that assumption that if we have good emotion predictor, it should be a good emotion generator. It's like 70%. So it means that if we want to evaluate emotion generation score, we should evaluate itself. We can't evaluate something else and conclude that our model is good in that metric, so we can conclude it can be good in emotion generation. So this is the conclusion here for this follow-up experiment. And then we have video modality. For video modality, we choose 4 different emotional video generation models and 8 different matrix. 4 of them are MLLM based evaluation matrix, and for the rest 4 are about feature comparison and video quality. And again, we choose almost 300 samples for each generative models. We did it for 4 models, so we have 140 different annotators using prolific and application. The best video generation model is Imogen, and the worst one is Live Portrait. Between these 4 different generative models, again, we have this correlation table. But here we have 2 different values, one for correlation, because we had 2 different human evaluation, one for silence videos, one for videos with audio, the normal videos. Why? Because we wanted to know that what is the effect of audio on the mindset of our annotators, of the final results of our experiments. So we have 2 different tag sets, one for 2 different annotations, one for silence videos, one for actually normal videos. And for both of them, the best one, as you can see here, if we have silence video, the accuracy decreased, because it's obvious, because we have less information for our annotators, so they may make wrong decisions. So here is their results. As you can see, the best one is Imogen, and these are the scores for different matrix, but the best one, the most reliable one, is Cohen in silence video. V means video only, and VT means video plus transcript, or plus actually the content of the video. So the correlation is like 54%. It's not really high, but it's the best one for video. But as I mentioned before, for text modality, we had almost 100% correlation, but here it's like 50%. So we need to work more for video and audio for other modalities to have more reliable metrics, more reliable uh, models, everything is weaker here. And the best one, as I mentioned before, is Quen in silence mode as a MLLM metric. This is one of the example in our data set. And as you can see here, the top one is generated one, and the this is in the bottom is the original one. And we had actually, I should mention it. We had a video quality experiment, video quality annotation for our annotators, and asked them, are these videos are good for detecting the emotions or not? And we mentioned three different labels like poor, fair, good. Poor means it's not detectable. The emotion in the video is not detectable. The quality of video is really low. So it doesn't mean that the video is really um, the quality of video is really low. It means it's not enough for detecting the emotion, I mean. So because some of the videos have they have some problems that the user cannot detect easily the emotions in the video, like this one. And as you can see, even for some poor videos, the predicted emotion and the given and the target emotion are the same, but for some good videos it's not the same. So it means sometimes it's not correlated. So it shows in the last slide here the correlation between uh, the quality of the videos and the human evaluation on emotional generation is negative. It doesn't mean that if we have l- less quality in our generation, we have more emotional video. It means most of the models that are really good in emotional generation, the quality there is not good. It means their focus on their paper just was on emotion quality, not on the quality of the whole video. So it means if both are higher, we have better video, we have better results in both. But it, for example, for live portrait, their focus was more on the quality, not the emotion itself. The meaning here is this, the meaning of these results. So after it, for audio modality, we uh, used 10 different audio generative models, emotional audio uh, generation models, and we use these are all, some of them are LLM based, like this one that used some prompt. Some of them can accept some prompts to change the emotion or changing the actually features of the video, like it should be rainy. For example, you can mention in the prompt that the audio should be rainy, or and you can mention your emotion there by prompt, but some of them are based on some specific text set, like emotional text set. You can just choose a specific emotion there. And for commercial one, I think OpenAI, you can put uh, for those, for these commercial methods, you can put your prompt. Also for this one, for the rest 7 models, you just allow to put your emotion there. And we choose 11 different metrics, one for speaker recognition to see that the speaker is the same in the generated and original audio or not. 5 feature comparison metrics metrics and five nearest emotion. Feature comparison means if we have two audio, we want to compare these two audio and measure the error, measure the actually difference between them. We can calculate some embedding, some feature space, and then compare those feature space with together. For nearest emotion, it means that we use those feature comparison methods to find the nearest emotion in this space. What does it mean? For example, if if we want to know if we have a happy audio, if we have a happy audio as an original audio, if we try to generate like if we have seven different emotions, we then generate seven different emotional audio like happiness, like angriness, or other audios. And the obvious thing here is the correct one is then that the nearest emotion to the nearest actually embedding to target the target audio should be the same, the emotion should be the same. For example, if we have seven different emotions, we will have seven different audios, and the nearest one should be happy because the original audio was happy. So if it is like neutral or something else, it means we have some mistakes here. This is the idea of these metrics. These metrics. So we have 11 different metrics here. And for human evaluation, unfortunately, it's not ready yet, but it will be ready maybe next month. And we will have the results for that. And then we can decide which one is more reliable, which metrics in the our automatic matrix. After all, here in the current state of my project, of our project, we are in emotion. After defining emotion, we are in evaluation. It's almost done. We have it for audio, for video and text modalities. For audio is almost done, maybe next month. After evaluation, we will go for training new model. How? Um, we now know which generative model is the best for generating text, audio, video. Sorry, for text and video, and hopefully next month for audio. And we have also some, we know that what is the most reliable automatic metric for different modalities. So we can use this knowledge for training the best emotional for generating, for augmenting new data using the best models for different using for different modalities, and we will have a really larger data set for our training, for our fine-tuning purposes. So because the emotional data sets are really limited, so we need to augment these data sets using different faces, using different voice tones, using different contents. So this is our synthetic data set that we can make. And also we can use automatic evaluation metrics as a loss function. So in this way, we can train new end-to-end model for emotional system, and this model should be hopefully should be better than these current models that we have. And also this model is end-to-end, not component based. So this is the features of this new model that we will make it. After this emotion steps, we will go towards more empathy with the same steps. definition, evaluation, and model training. It maybe it's like for next year. But finally, we will have a really empathetic system that is an end-to-end model with different reliable automatic evaluation metric. And thank you for your attention. If you have any question, feel free to ask. Thank you.
I have one quick question regarding the evaluation of the video aspect of it. So you did mention like couple of models, right?
Mhm.
So what are the generated videos from those models? So you'll be giving an photo and they'll generate the video out of it, or how is it?
Mhm. Here we
Yeah.
have four different video generation models.
Uh-huh.
Three of them accept um, emotion tag,
Mm-hmm.
target emotion, audio, reference audio, and the picture, reference picture as a picture of the person.
Mm-hmm.
But one of them that is live portrait try to mimic the original video, you know,
Okay.
without asking any emotion. So they have better quality
Mm-hmm.
but less emotion performance.
Okay. Got it. Got it.
Mhm.
And so for all of these models, right? So did you also try, I mean, all these are all open source models, right?
Yes, yes.
Did you try with even like maybe Sora or V?
Uh, the problem is our data is private because of the
Okay.
ethical concern. We just for text modality there is no problem because we use the content itself
Yeah.
without the pictures,
Uh,
without yeah, that's
yeah.
the
Makes sense. Yeah. And one more final question is, like, what if someone wants to try like evaluating some model, like whether it's a text modality or video modality, like what would you prefer them going in terms of which metric they should choose for evaluating like emotion, like empathy part of it, like emotion part of it.
Mhm. For now, we know that the best using MLLM metrics is Quen in silence mode.
Mm-hmm.
If someone want to use automatic metrics, and if they don't want to use MLLM, this metric is also reliable. It's like 49% correlation score. CPBD. It's one of the metrics for just measuring the quality of video in some way. So that one is also feasible.
Oh, okay, makes sense. And I assume that like it's a paper. I don't think paper is published, right? Because
Yes.
you have to do a couple more works in terms of evaluating, and after that you'll publish the paper.
Yeah. Yeah. It's like maybe hopefully 2 or 3 months later, I think.
Ah, okay, makes sense. Yeah.
Then the results are ready, but we are waiting for the reviewers.
Mm, okay, gotcha. Gotcha. Okay, thank you.
You're welcome.
Yeah, thank you, Philip, for giving the great session, and I'll just contact you. I don't think the results, yeah, slides you can't share, right? Because it's
Mhm.
yeah, gotcha. Okay, anyway, thank you for giving the great session, and have a
Thank
great.
you too for inviting me. Thank you.
Yeah, see
Have a
you.
nice- See you. Bye bye.